Okay guys, let's work on our first review coming up for our quiz on exponents and radicals. Quite a few things here. Let's just take a look and see where we are. First one is to rewrite in exponential notation. So if I've got the fifth root of x cubed, that is the same as x to the 3/5 power. That's what the fifth root of x cubed means. Number two, rewrite this in radical notation. This is the fourth root of 5 cubed, or you could write it like this, the fourth root of 5, all of that cubed. It doesn't matter which order we do that. So the fourth root of 5, all of that cubed, or the fourth root of 5 cubed, either way. Simplifying expressions. So this is where we're going to have to use our organization skills with radicals. So number 3 is dealing with square roots. So if I look at 45, I can write that as the square root of, this is 9 times 5. That gives me a perfect square of 9. And I'm going to write this as a to the 5th, a to the 5th. Let me back up, sorry. I didn't mean to do that. So perfect squares. So really it's a squared, a squared, a squared, a squared, a squared. There are 5 of them, okay? That's a to the 10th, b to the 6th. So that's b squared, b squared, b squared, and c. Now if I look at everything that's a perfect square, the 9, all of the a's, and all of the b's, okay? The square root of 9 is 3. The square root of a squared is a. How many of them do I have? I have 5 of them. The square root of b squared is b. It looks like I have 3 of those. I am left with the square root of 5c. 3a to the 5th, b cubed, square root of 5c. Number 4, looks like I am adding expressions with radicals. So it's square roots. I want to organize everything I can as perfect squares. So this is 2 times the square root of 25 times 2 minus 10 times the square root of 2 plus the square root of 16 is 4. So this is 3 times 4. Okay. If I look at the first expression, square root of 25 is 5. So this is 5 times 2, square root of 2, minus 10 square root of 2, plus 12. So this is 10 square root of 2 minus 10 square root of 2 plus 12. That all equals 12. Number 5, continuing on with fourth roots, okay? I want to organize everything under the radical as powers of 4. So if I look at it, I know that 48 is 16 times 4. But if I can't recognize that right off, let's divide 48 by 2 and we get 24. Divide by 2 again and I get 12. Divide by 2 and I get 6. Divide by 2 and I get 3. I count 4 2's there. So this is 2 to the 4th times 3, or 16 times 3. And then 162, if I look at 162, if I divide it by 2, I get 81. Divide by 3, I get 27. Divide by 3, I get 9. Divide by 3, I get 3. So there are 4 3's. This is 3 to the 4th times 2. So again, I'm trying to organize as powers of 4. So this is negative 2, and then I'm taking the fourth root of 16 times 3 plus 2 times the fourth root of 3 to the 4th times 2, or 81 times 2. So the fourth root of 16, that is 2. So I get negative 2 times 2 and the fourth root of 3, plus 2 times the fourth root of 3 to the 4th is 3. I'm left with the fourth root of 2. So this is negative 4, fourth root of 3, plus 6, fourth root of 2. And that is as far as I can go on that one. Negative 4, fourth root of 3, plus 6 times the fourth root of 2 is my final answer there. Number 6, fourth root of 8x cubed times the fourth root of 2x squared. When I'm multiplying, I can often get something simpler if I would combine the radicand by just multiplying. This is going to be 16x to the 5th, okay? So fourth root, I know the fourth root of 16 is 2. So this is 2 times the fourth root of, when I write x to the 5th, I'm going to write it as x to the 4th times x. So this is going to be 2x fourth root of x, because the fourth root of x to the 4th is x. Number 7, fifth root of 64 b to the 6th, okay? So I'm going to write this as the fifth root of, I'm going to write this as 32 times 2, and b to the 5th times b. The fifth root of 32 is 2. The fifth root of b to the 5th is b. And that leaves me with the fifth root of 2b. So 2b times the fifth root of 2b is the answer here. Number 8, I got lots of exponents, lots of negative ones. The first thing I want to do is just take care of this negative exponent out by itself. So to make that a positive exponent, I basically just flip everything. 3x cubed y over 2xy squared z to the negative 2 squared, okay? Now I need to simplify everything. I got choices. I can square everything and then simplify, or I can simplify first. I'm going to try to simplify what's in the square, in the parentheses first. So this is going to be 3x to the 3 minus 1, y to the 1 minus 2 over 2z to the negative 2 squared, okay? So this is 3x squared, what, y to the negative 1 over 2z to the negative 2 squared. Now take care of those negative exponents inside. This is 3x squared z squared over 2y, all of that squared. So my final answer is going to be 9x to the 4th z to the 4th over 4y squared. And that's as simple as that one gets. A lot of places for mistakes on this one. So again, my key was when I started out, take care of this negative 2 exponent, make it a positive 2 by just flipping everything. 3x cubed y over 2xy squared z to the negative 2. And then I just use the quotient property for exponents. 3x to the 3 minus 1, y to the 1 minus 2 over 2z to the negative 2. That gave me 3 times x squared, y to the negative 1 over 2z to the negative 2. Take care of those negative exponents inside and square everything at the end. Again, many different ways to go about this. You could have just distributed this negative 2 exponent through everything and then simplified. So as long as you're obeying the rules of exponents, you should get to the same answer that I got. Let's look at the next one here. X's, Y's, and Z's, and we're trying to confuse you, okay? I look at this and let's just say, okay, this is going to be x to the 2 minus negative 2, y to the negative 2 minus 4, z to the 3 minus negative 5. So that's going to be x to the 4th, y to the negative 6, z to the 8th, which is just x to the 4th, z to the 8th, over y to the 6. Mainly properties of negative exponents here. This one, if it takes you more than a second, you're doing it wrong. You got this big whole complicated thing in the parentheses raised to the 0 power. That's 1. So this is the 7th root of 1. What number can be multiplied by itself 7 times and give you a 1? That answer is 1. Okay? This is just wanting to see that you know properties of exponents, mainly a 0 exponent. So there was no need to do a lot of work inside the parentheses on that one. Evaluate the following expressions or numerical values showing your work. So this is the cube root of negative 64. When I get that number, I will square it, okay? Cube root of negative 64. What number can be multiplied by itself 3 times and give you a negative 64? This is negative 4 squared, which is 16. Number 12. I've got a negative exponent. I would rather that be a positive exponent. That is very easy to change. If I write this as 16 over 25, that is now to the 3/2 power. What does that mean? That means the square root of 16 over 25. I'll get that number and I will cube it. What's the square root of 16? That is 4. The square root of 25 is 5. So this is 4/5 cubed. 4 cubed is 64. 5 cubed is 125. 64 over 125 is my answer. Number 13, I am multiplying expressions with radicals. You often have a much better shot of simplifying if I write this the cube root of 9 times 6. That is the cube root of 54. If I have a shot of simplifying, I want to organize things as perfect cubes. 54 can be written as 2 times 27. We already know 27 is 3 cubed. If you don't know it, you can validate that every time. So this is 2 times 3 cubed. So this is the cube root of 2 times 3 cubed. Cube root of 3 cubed is 3. This final answer is 3 times the cube root of 2. Number 14, okay? What does this mean? This means the cube root of 27 times the square root of 64. What's the cube root of 27? That's 3. What's the square root of 64? That's 8. When you multiply those numbers, you get 24. Number 15, negative 8 to the negative 2/3, okay? Negative exponent is the first thing that's bothering me. So I'm going to write this as negative 8 over 1 to the negative 2/3. To get rid of that negative exponent, or to make it positive, I'm going to have negative 1 over 8. I flip that fraction, and now I get a positive exponent, okay? So this is the cube root of negative 1/8. I'm going to get that number and square it, okay? Cube root of negative 1/8. I know the cube root of 8 is 2, so the cube root of 1/8 has to be 1/2. Cube root of negative 1/8 has to be negative 1/2, because negative 1/2 times negative 1/2 times negative 1/2 is negative 1/8. So this is negative 1/2 squared, which is 1/4. 81 to the 1/4 times 81 to the 1/2. This is the 4th root of 81 times the 4th, times the square root of 81. Okay, square root of 81, that's 9. Fourth root of 81. What number can be multiplied by itself 4 times and give me an 81? Well, if I divide it by 3, I get 27. 3 to the fourth is 81. Fourth root of 81 is 3. Multiply 9 and 3 and you get 27. Rationalizing the denominator. I don't think you guys liked this last semester. I'm not sure if you're going to like it this one, but here we go. I want the denominator to have no radicals, okay? So if I look at number 17, I've got the fifth root of 2. If I have any hope of simplifying a fifth root, I need the fifth root of something to the fifth power, okay? Right now I have the fifth root of 2 to the first power. So in order to rationalize this, I'm going to have to multiply by something that will give me fifth root of 2 to the fifth at the bottom. That's going to be the fifth root of 2 to the fourth. So I'm going to multiply by 1 in this special form. Fifth root of 2 to the 4 over fifth root of 2 to the 4. So on the top, I get the fifth root of 2 to the fourth. When I multiply the fifth root of 2 times the fifth root of 2 to the fourth, I get the fifth root of 2 to the fifth. The fifth root of the 2 to the fifth is 2. So this is the fifth root of 2 to the fourth over 2, which is the fifth root of 16 over 2. I think either of those answers would be good, okay? I think the number 18 is a little bit easier. Square root. So that means I really want to take the square root of something squared. So if I've got the square root of 3 here, to make it something squared, I'm going to multiply by square root of 3 over square root of 3. Then I get 7 square root of 3. And over in the bottom, I get the square root of 3 squared. The square root of 3 squared, that's the square root of 9. That's 3. Your answer is just 7/3 square root of 3, or 7 square root of 3 over 3. Number 19. The negative is there just to bug you and see if you can keep track of it. But here, I've got 2 plus square root of 2. We did this kind of thing last semester, so nothing's really changed. So if I've got 2 plus square root of 2, I'm going to rationalize in it by multiplying by 2 minus square root of 2 over 2 minus square root of 2. On the top, I'm going to get negative 2 minus square root of 2. And on the bottom, I get 2 plus square root of 2 times 2 minus square root of 2. I will need to FOIL that. So I will get negative 2 minus root 2. When I multiply the 2 and the 2, I get 4. The outside terms, when I multiply the outside terms, I get minus 2 root 2. When I multiply the inside terms, I get plus 2 root 2. And when I multiply the last terms, I get minus square root of 2 square root of 2. So what happens here is 2 square root of 2 minus 2 square root of 2, those go away. So I get negative of 2 minus root 2 over 4. And then the square root of 2 times the square root of 2. So remember, square root of 2 square root of 2 is the same as the square root of 4. That is 2. So on the bottom, I get 4 minus 2. So I get negative 2 minus root 2 over 2. That's one way of writing your answer. If you distribute that negative sign up top, you could get negative 2 plus root 2 over 2. That is another form of the correct answer on that one. Okay, that one just requires a lot of manipulation of terms to make that one work. But the key was you had to multiply this by 1 in the form of its irrational conjugate. Okay. Number 20, I need the cube root of 3 to go away. Since it's cube roots, I want to take the cube root of something cubed. Here is the cube root of 3 to the 1. So I'm going to need to multiply this. So that's the cube root of 3 to the 1. I'm going to need to multiply by the cube root of 3 squared over the cube root of 3 squared. When I do that, I will get 3 times the cube root of 9 over, this is going to be the cube root of 3 cubed. That's why I multiply by the cube root of 3 squared. So the cube root of 3 squared times the cube root of 3 to the first is the cube root of 3 squared. The cube root of 3 squared is 3. So this is 3 cube root of 9 over 3. 3 over 3 is 1. Your answer here is the cube root of 9 or the cube root of 3 squared. Either one is that. Okay, so again, that should be the end of this review. Quite a bit of stuff. You need to be very comfortable with the with the radicals and with the exponents going back and forth, and then rationalizing denominators, which is one of the last topics that we covered.